Hey JT, I just saw that you were signed on. Sorry about that. I was looking away and I see that your microphone is muted. So I just chatted you in the chat window. Can you hear me or is my microphone muted? Oh, okay. Do you have a question or did you just show up to hang out? Are you there? Oh, okay. Well, good. I did number 15 for you. Can you see it? Okay. Well, I was just planning on working them going as I go through math lab to work each individual one. And I'm still kind of playing with a new screen capture feature that I am. So it might be a little awkward, but do you mind working with me? It's nice to have a friendly source. Thank you. I'll I'll let you get caught up. Have you already started? Have you watched the video yet? Okay, cool. Well, then we can actually do the homework together if you want. There's number 15. Yes, it is me that does the math labs every Tuesday and Thursday. When do you have chemistry lab? I'm trying to figure that whole thing out too and work around it because I've been doing math lab at noon, but I know most of the juniors have chem lab on Tuesday in the morning. So I'm kind of thinking that an afternoon one, even later than noon, because I know the last math lab is from 12 to 1:30. So I'm wondering if I should do math labs at like, okay. I'm wondering if I should do math lab because I think they start like at 8 o'clock on Tuesday morning, but or 8 or 9 o'clock on Tuesday morning. So I'm wondering if a math lab at 2 o'clock in the afternoon would be better for most of the juniors. What are your thoughts? Would you, or at least would you ask the other students in your class? I'll have Miss Stone do it and too. Okay, I have to shut the chat window for a minute to go back and work number 17. Basically, what you want to do is regroup because multiplication is a commutative and associative property. So we're going to switch. the non-exponented numbers into a parenthesis together, and then put the exponent, base and exponent numbers together. Wow. As I said, I am experimenting with the new stylus. So my writing's going to be really nice. So then you multiply those. And then 5 plus a negative 12 is going to give me -7. And then I have to move, in order for it to be true scientific notation, I have to move this decimal 1, which means I'm going to be multiplying by 10 to the first, essentially, to do that. Does that make sense? And then I've got to combine the +1 and the -7. I would have actually technically regrouped this part here to be together. So that's going to be 10 to the -6. All right. Oh, you work. Okay. So you have to be at work by 2. Is that every Tuesday? Okay. Yee. Is it Thursdays as well? Or do you know your work schedule for Thursday? Okay. Everybody's so busy. I guess, I don't know. I guess I'll stick to it at noon. It is recorded, which, that's embarrassing for me, just overall awkward. So I guess people can go back and watch them if they need to. I have to figure out how to post that part. Okay. So I don't know. I guess I'll keep it at noon. I know Mackenzie's in that 12 o'clock noon math lab. Grace Chapman is. Levi is. Kendall is. I'm trying to think of who else is. Rose. I'm not sure. Is Rose in your math class? Oh, and no, there are not usually more people at this math lab. I usually have, I've only had, I don't think I've ever had more than 2 at Algebra 2, and I usually only have one person. So usually it's a one-on-one tutoring service. I've done it for one. You're the second person in Miss Stone's class that I have. And then I've had one person in my class show up, and she showed up on Tuesday, and we worked through the review guide together. the chapter review that was assigned on Tuesday. We did, I don't even remember how many problems we did on that, 6 or 7 on that. Oh, well, I was here and I worked out all the problems. Come visit me more often, JT. I don't know if Miss Stone gives extra credit, but I gave some bonus points if they needed it. If you show up to math lab and you need some bonus points, because I do have a lot in Algebra 1 that show up. And I always let Miss Stone know that somebody shows up for math lab and asks questions, just so that she knows, that y'all are trying, because that's really important to both of us. So anytime you have questions, and you can always email either one of us, but if you have a specific thing, like let's say you can't show up to math lab, you can always email me with a specific question, and I'll be sure and cover that first, so that if you do have to go back and watch the recorded one, I'll be working it out and you can see it done. So I just have to figure out how to post the recorded version. Have you gotten down 15 and 17? Do you want me to move on, or do you have any questions about those? Okay, cool. Well, I won't erase it then, because it's just you and I. So I'll go as slow as you need me to while you get them written down. Plus, I'm asking you a ton of questions, so you have to type and write. As you're writing it down, just to make sure that I clarified why you have to move the decimal over 1 in order for it to be true scientific notation. There can only be one number to the left of the decimal for scientific notation. And so you have to adjust your exponent on your base 10 in order to accommodate however you have to adjust. Yes, when you move it to the left one, you're adding an exponent. You're going up in exponents. If for any reason you ever have to move it to the right, you would be going down an exponent, because you're I don't know if that makes sense, but there would be those scenarios sometimes where you would have to move it to the right. So yes, your adjustment, it's this line. Let me go back to here. It's this line right here, which is kind of messy, but this is where I've added. I'm basically, when I move it here to the right, I'm multiplying it by 10 to the first. Or actually, I would be multiplying 5.607 to 10 to the first in order to make 5607. So technically, I guess you'd say I'm almost dividing, but what I'm doing is showing that 56.07 is the same thing as 5.607 times 10 to the first. And then I'm taking this 10 to the first and adding it here, which gives me 1 plus -7. So my final answer then is 5.607 times 10 to the sixth. Does that make sense? Okay, cool. All right. Now I got to go back and erase. So wish me luck on that. Oh, it's working. Some days it doesn't work for me as well. How's your brother feeling? I know you're going to type the answer and I'm not going to be able to see. Hold on. The little dots seem to be the hard ones to take care of. Oh, I'm glad that your brother's feeling better. So he's coming back to school tomorrow? Cool. All right, 19. So what we have here is we've got 2.1. It's cubing everything inside the parentheses. So we've got 2.1 cubed, and we've got 10 to the fourth, 10 to the negative fourth cubed. So you have to make sure that you're cubing both the 2.1 and the 10 to the fourth. So 2.1 raised to the third is 9.261. And then by my exponent rules, I'm going to be multiplying that really nice looking negative 4. Negative 4 times 3 in that second part, which is going to be 10 to the negative 12. And so since this doesn't have to be adjusted in any way, it's actually in scientific notation already, because there's only one digit to the left of the decimal, I would just rewrite it as 9.261 times 10 to the negative 12. And that's your final answer. Any questions about that one? Just making sure that you apply exponent rules is the most important thing, making sure that you cube both whatever's inside, both numbers inside the parentheses. Okay, you ready to move to 21? Yes. I'm going to the memorizing the exponent rules for the tests and quizzes. Yes, I would say, I would think for the homework and stuff like that, you could definitely use it as a reference, but eventually, you're going to have to memorize those. So I'll make sure that, like in the next part, that I'm saying them over and over again. So hopefully they'll maybe start to stick a little bit better. But just knowing when you multiply exponents, if the bases are the same, then you're adding if the bases are the same, then you add the exponents. If you're multiplying, like if it's a power raised to another power, that's when you multiply the two exponents. And when it's a division problem, you're going to subtract, which we'll see in number 21. That's how we're going to work that one. So I'll make sure that I'm stating them, so hopefully they become maybe a little more ingrained, and maybe they'll make a little bit more sense. It's like division goes with subtraction, and multiplication goes with addition, and then a power to a power is when you're doing multiplication of exponents. So that's kind of the basic rule for it. But if I keep repeating it, it'll stick better. Okay, 21. Somebody told me the writing was really, really small the other day. Let me switch back to see what you say to answer this question. Is the writing really small, or can you see it okay? Okay, cool. All right, 21. On this particular one, it's kind of like we're going to work with two division problems, really. Um, Even though typically I know that PEMDAS or GEMDAS kind of tells us that we need to deal with, a grouping being the top of the fraction bar or the bottom of a fraction bar. But for this particular case, when it's in scientific notation, we want to do the division of 8.1 divided by 5.4 first, and then deal with the 10 to the 12th power divided by 10 to the 9th power, so that we can use our exponent rules. So when you're plugging this in your calculator, you're actually going to plug in 8.1 divided by 5.4 in order at first. And so that would look like 8.1 divided by 5.4 and one section. Wow, that writing though. And then 10 to the 12th divided by 10 to the 9th. So this equals 1.5. And then here, you're going to subtract 12 minus 9. And that's going to give you 10 to the 3rd. Does that make sense? Clear as mud? Okay. That one's not too awful bad. 23 looks like it's going to be fun, though. Once again, I think that is going to be able to address a little bit of my PEMDAS that I was just talking about, because there's actually a multiplication on the fraction bar, on the top part of the fraction bar, which is technically a grouping. So you do have to handle that first. And then once we get the solution to that, then we'll divide that by the 1.5. We'll isolate the 1.5 scientific notation number on the bottom of the fraction bar. So we're going to be doing it in two separate parts. I'm going to erase 21 so that I have plenty of room. So 23. Wow. Not so good with the stylus. So I'm going to, instead of rewriting the whole problem, since I don't have a lot of room, I'm going to go ahead and regroup what's on the top by doing 7.5 times 4.5. And then I've got that's 10 to the, not 10 point, but 10 raised to the 8th times 10 to the negative 4th, all over 1.5 times 10 to the 7th. So I will multiply 7.5 times 4.5, and I get 33.75. And then I'm going to add my exponents in that second part. And I've got 10. That's 8 plus a negative 4, which is going to give me 10 to the 4th. And then I noticed that this 33.75 is not in scientific notation. So in order to get it in scientific notation, I have to move my caret, and I'm moving my decimal. Let me go ahead and write my denominator again. So that's going to tell me I've got 3.375 times 10 to the 1st. And then I can kind of regroup this, times 10 to the 4th, all over 1.5 times 10 to the 7th. Now I'm going to add this exponent with this exponent. And so on the top, I'm going to have 3.375 times 10 to the 5th, because I'm adding those two exponents, all over 1.5 times 10 to the 7th. And then now I get to, are you caught up to me? I'm sure you probably are. Writing with this as slow as Christmas. So you caught up? I see a yes there, but I didn't know if that was from another question. So I'm going to erase the top part. So I can continue the problem up here. And now this next part, I'm going to do the division problem like I did in number 21. And I'm going to separate the 3.375, beautiful numbers, 1.5, and then put this over here. I can't even tell that that's a 7 down there. So I'll take, once again, putting in my calculator, 3.375 divided by 1.5. And that gives me 2.25. And then I'm going to subtract 5 minus 7, which gives me 10 to the negative 2. And that's my final answer for that one. So I don't think I skipped a step, and I went painfully through each one, but I was hoping that that would clarify a little bit of how you handle the scientific notation part. And also in a division problem, you're subtracting your exponents as long as your base is the same. So, you know, like I say, division, as long as the bases are the same, In a division problem, you're just subtracting the exponents, but the bases have to be the same. And you'll see that a little bit more when we go to the next section, because we'll be taking each individual variable. Most of them are variables. Some have constants next to them, and dealing with the actual exponents themselves. And I think as you work through it, those exponent rules will become a little clearer, because working with them, actually seeing the pictures of them and seeing the rules themselves can be a little daunting when looking at them. But once you start working with them and doing it over and over again, it becomes a little clearer. Are you ready to move on to 20? What are we on? 25? Okay. Let me erase what we have here. The dots are hard to get rid of. Okay, 25. So we have 2 squared y cubed all raised to the 5th power. So PEMDAS tells us we have to deal with the exponent first. So you're going to multiply 5 to each of these exponents, because when a power is raised to a power, that's when you actually do multiplication. So 2 times 5 is 10. So then we have 2 raised to the 10th power and y raised to the 15th power. So then 2, do that one on your calculator, because I'm not absolutely positive on that one. It's 1,024 y to the 15th. Hold on just 1 minute. Okay, did you get that? Oh, wait, let me swap window. Okay. And then it's part of the, hold on again. The struggle's real sometimes. The properties used are the power of a product property and the power of a power property. I wanted to make sure I stated those right. And the power of a power is when you're raising one power to another power. And because you're multiplying the 2 and the 5. Okay. Is that what you were asked? Is that why you were asking about that though? Is to be able to state them? Do you have to memorize the exponent rules, not just how to use them, but actually what their names are? Is that why you were asking, or were you asking how to use them? I don't think anywhere on the test we act. Okay, all right, how to use them? Yeah, I don't think on a test we actually ask you to name them. We do expect that you'll know how to use them, but we don't ask you to name them. But hopefully, with some practice, it won't be too much of an issue. All right. I'm erasing. I didn't ask you if I can erase. I hope that's okay. Okay, number 27. On this one, we don't have any exponents outside of the parentheses. So all we're going to do is do some combining of exponents. So you've got the 3 and the 6 here on the W's. So all we're going to do is add, oh my. And you can actually, because it's multiplication is commutative and associative, you can actually regroup them. So if I put them next to each other, each of the variables next to each other, maybe that'll even clarify it a little bit more for you. What you're doing is actually combining the 3 and the 6. So I'll have W to the 9th and combining the -2 with the -1. And that's going to give me X to the -3. And you're not supposed to have negative exponents in your final answer. So negative exponents, when they get transferred to the opposite of where they are. And I say that because if, for instance, that this happened to be in the denominator as opposed to being raised like that, it actually would flip to the numerator. So you move it to the opposite of where it is. Hopefully there'll be an example of that. But this is your final answer. Negative exponents get pushed away from wherever they are. So if it's down here, it goes to the top. And if it's up here, like this one is, it goes to the bottom. But that's your final answer for 27. Was that? The last thing you texted was it is. So was that a question to me? Or did? Oh, okay. All right. So, um, okay. All right. I don't want to. I wish I could see the other screen while I was doing this, but this part is big on my screen so that I can write a little bigger. That was to resolve some of the other issues of it being kind of small. All right. 29. Once again, we're going to the power of a product. So we've got 3 raised to the -3rd. We've got A, and then that's going to be 3 times -3. So that's going to be -9. And then B we've got 5 times a negative 3, which is going to be negative 15. Now, all of these are negative, and they're also in quote unquote in the numerator, because technically this could be stated as all over 1. So because all of these are negative, they're going to be shoved to the denominator. So it's going to reverse to 1 over, and then 3 raised to the third power is 27. And that will be A to the 9th and B to the 15th. And that lovely answer is your final answer. Did writing it over 1 kind of help you understand how it gets pushed down, or were you even struggling with it? No, the 27 is not negative. The only way the 27 would be negative is if the 3 itself were negative, and it wasn't, right? It just only, yeah, I had to double check it. Now, if the 3 inside the parentheses would have also been a negative, then it would have been a negative 27, because negative 3 times negative 3 is a positive 9, but a positive 9 times a negative 3 would have made it a negative 27. The negative exponent is what makes it go to the denominator. But the answer itself to the power is still positive. Okay. Did that clarify that for you? Cool. All right. Are you ready to move to the next one? Okay, cool. 31. Mm-hmm. Okay. JT, Mr. Bill said hi. He just walked in the house, so I needed to warn him that I was on Math Lab.
Yes, JC, if you ran 5 miles today.
JT, Mr. Bill wants to know if you've run 5 miles yet today. He hasn't answered yet. I'm going to take that as a no. He said, tell him hi for me and not yet. So at least he's planning on it.
All right, there you go.
And I think he's going to work later. All right. Which one are we on? Oh, number 31. I digress. Okay. Now on this one, we've got a little bit like a couple of them that we were dealing with earlier. We're taking each individual like constant and variable and dealing with them separately. So we're going to start here. 3 divided by 9. So that's going to leave me, that technically it would be like 1/3 because it reduces like a fraction, but I really don't have to write the 1. That's kind of moot, but I just kind of wanted to show you basically what you're doing is rewriting the fraction in its lowest terms. And then you've got 3, and then the understood exponent here is a 1. So you've got 3 minus 1, which is a positive 2. So that stays on top. And then you've got here the understood 1, which is 1 minus minus 1. Crazy, huh? So that's a positive 2. So that goes on top. Did that make sense? Because that's 1 minus minus 1. So your final answer is C squared D squared all over 3. Pretty 3, Miss Sparks. So did you understand where I got the 1 minus minus 1 on the D, on the variable D? Okay. So basically what you're doing is breaking down each individual, like first the constants, you have to deal with those. And then you take each variable and you deal with each one individually. All right, we can move to 31. Or is that the one we just did? That's the one we just did. Yay. I'm further ahead of myself than I thought. 33. Okay, once again, you would deal with the constants first, but they don't even reduce. So 2 over 3, there's no way to reduce that, so it just kind of remains the same. And then you've got a to the third minus a to the fifth. So 3 minus 5 is -2. So it stays in the denominator because it turns out to be a negative. Ugh. And then we've got b to the -4 with b to the -2. So that's technically -4 minus -2, which is -4 plus 2, which equals -2. So it's b to the second because it's negative. The exponent would end up being negative. So your final answer is 2 over 3a squared b squared. I'm going back to see if you have questions. Oh, yeah. It's really not too bad, just trying to keep things straight. And that's why I was saying is if you practice a few, the exponent rules don't seem as daunting because I don't know, for some reason, the association between a power raised to another power being multiplication, and when you're actually multiplying two exponents that have the same base, that you're really adding the exponents. And when you're dividing two exponents that have the same base, you're really subtraction. So division, subtraction, multiplication, addition seem pretty easy associated. So it's not as bad as long as you're practicing. Okay, 35. Oh, this one looks like fun. So what we're going to want to do is there's a number of ways that you can tackle this and it still be correct. But I think for me, I would go ahead and do the multiplication all the way across the top and then work with the division. So I think that's going to be my approach. But it wouldn't be wrong to solve each side first either. I think you would get the same answer. I could actually try it, but we've got x squared y to the negative third. So x squared y to the negative third, and then times y to the second all over 3y squared times x to the negative fourth. So I would do negative 3 plus 2. So that's going to give me x squared y negative 1 all over 3x to the negative fourth y squared. So my 3 is going to stay the same because there's nothing there. And then I've got 2 minus a minus 4 equals 6 because that changes to a plus.
Oh,
so
this is what we needed.
I've got x to the 6th. Oops, that shouldn't have been there.
Can you hear me?
Yes.
Oh, okay.
Hey, but I can't really see who's there because I'm working on a problem. But yes,
Yeah, you don't need to
I
see.
can hear you.
You don't need to see.
JT is on here with us, but he's
Yeah.
using the chat box.
Awesome. Well, you don't have to see me, so.
And then the last part of that is I've got negative 1 minus 2. So that's going to give me y to the negative third, which keeps it in the denominator. So this is the final answer for that one. X to the 6th over 3 times y to the third. I'm glad you're here, Adriana.
Thanks. Alyssa's with me too.
Hey, Alyssa.
Hi.
I actually have been going through all of the homework today, and we just finished number 35.
Awesome. Well, that's where we are. We just finished 35 too, so.
Yay. Okay, JT, do you have any questions on that one? Okay. And Adriana or Alyssa, do you have any questions on 35? Can you see it how I have it worked out there?
Yeah.
It's very pretty writing, I know.
Yeah, I can. Yeah. Yeah.
Is it my writing?
Just a little.
Just a little. Well, you know, the stylus, I'm going to blame it on the stylus.
Okay.
Totally blaming it on the stylus.
It's all good.
Okay. But the thought process, I kind of worked out the multiplication part first. So that's why I did the negative 3, like x squared y to the negative third times the y squared. And I just brought the x squared down, and then I combined these two exponents, negative 3 plus 2, which gave me a y to the negative 1 on the top. And then I combined the bottom together, which gave me 3x to the negative 4th y squared. And then for my final answer, my 3 remained on the bottom. Then I dealt with my x variables, which would be 2 minus a minus 4, which I wrote over here, which gave me a 6, a positive 6. So that would have put that in the numerator. And then my final one, I did the y negative 1. So negative 1 minus 2, negative 1 minus 2, which gives me a negative 3. So that's y to the negative third, or y to the positive third, which keeps it at the denominator. Is everybody good?
Yeah, we're good here.
Okay. All right, I'm going to go back and erase. But the next trick, what we had to go to what, 30 what?
9.
39?
Yeah.
So 30, I don't have a screenshot of 37 and 39, so I'll have to do that. I tried to do that on my other computer and then hurriedly get it over to you all.
Yeah. Well, do you need us to read it to you? Because we have it right here.
Well, I have to have some sort of PDF to write on it anyway, because I don't have anything else to write on. The only thing it allows me, the stylus really allows me to write on, is a PDF.
Well,
So
these
I'm
are pretty
kind of
simple.
stuck doing it this way, unfortunately.
Well, these are just describe and correct the error, and the errors are like pretty simple.
Oh, okay. So we could talk it out.
Okay.
Then I'll just screen share the book. Okay, so now y'all can watch it give me an error to log back in. Yay.
Do you know
I think it was
when?
page 92, right?
Yeah. Do you know when
Okay.
we're going to be getting our tests back by any chance?
I'm sorry?
Do you know roughly when we're going to get our tests back?
I can't actually hand the tests back because not everybody has finished yet, but I do have yours graded. I don't know if I put it in RenWeb, but after I get off here, I'll put it in RenWeb, and tomorrow you can always come and look at the test.
Okay, because I just want to know like how badly I failed.
You didn't.
I didn't fail? That would be like a
Yeah.
miracle from the Lord
No,
Jesus.
you did not.
Did I like barely pass?
No.
I'm going to look it up. Hold on.
Yeah. You give me about, I don't know, give me about 15 minutes.
Yeah, well, you don't have to put it in right now. It's fine. I can wait.
When we get off here,
Mhm.
and I'll have it in RenWeb and you can go check it.
Okay. I mean, it's not like no hassle.
Okay. It was not a big deal. I mean, I like getting all that stuff done anyway, but I just got through going through all the homework too. So that grade will be in there as well. The classwork and the class participation grade.
Okay.
So, and you got bonus for coming to math lab.
How much bonus?
I can't remember what it was.
It's okay. It counts.
Yeah,
Everything
I can't remember. 2 or 3 points.
Okay, that's good.
Okay, number 37. Can you all tell me what the error is?
They divided instead of subtracting.
That's it. Exactly. So the right answer should have been,
X to the 8th.
that's correct. How about 39?
Hold on. They multiplied everything instead of adding the exponents.
Well,
Right? Wait, no, wait, that's wrong.
they did add the exponents.
It would be, they didn't do like negative third to the second times negative third to the fourth and then simplified it. They just did like
Separately?
negative third times negative third and then added the exponents.
Well, since the base stayed the same, the base should have stayed the same. Does that make sense?
Oh,
That probably didn't make really any sense at all, but
Nope,
it
not
should be -3 raised to the 6th power. Because the base stays the same. Make sense?
kind of. I mean, I'm probably gonna
Kind of, but
forget
not
that.
really.
I mean, I just don't see why you wouldn't multiply it because you do like on everything else. So why would you not now?
So it's
Um,
-3.
Yeah.
Because technically what you're saying is it's negative. It would be like if there were an X there.
Mm-hmm.
If there were an X there instead of the 3, like if it was X to the 2nd and X to the 4th, you would just put X to the 6th, right?
Yes.
Yes?
Yes, sorry.
Okay. So it's just, we get kind of caught off guard when all of a sudden they start putting real numbers there. It's when the base is the same, it just kind of stays the same across the board. I don't know if I'm making sense as I'm speaking it or not.
It makes more sense. So
But the -3 would stay the same. And then I feel like it's extra confusing for whatever reason when students see the -3. They feel like they need to treat it differently, but really it's just a base. The base stays the same.
okay, that makes sense. Okay, well, thank you.
So it just stays -3 raised to the 6th.
Okay, I'll remember that.
Yeah. Because technically, if you would have multiplied it, you would have actually been taking away. Oh, JT had to go to work and he said,
Bye.
bye to everybody, and including Adriana and Alyssa. He said goodbye to y'all because he can see that you're on there. But he had to go to work.
Okay. Well, at least he makes money. That's
No, he
nice.
didn't say bye to me. That's okay.
Okay.
Let's see. Can you see the chat window?
Yes, ma'am.
Oh, okay. I didn't, and I'm trying to figure out if that shows up in the recording also.
No, we can't see it like on your screen.
But you can see if we chat.
Yes.
Yes, just not as if it were on your screen.
I got you. Oh, okay.
Yeah, it cuts out like all the corners on your screen.
Oh.
Ooh, you had a notebook check.
Crap, what?
Yesterday?
All right, so we got all the homework done.
Okay, awesome. Okay, well, thank you. We have volleyball tonight, so we need to keep going on school.
Okay. Since they were odd, you were able to check them in the back of the book, correct?
We could have. We just haven't yet because we started school like an hour ago because we were eating biscuits.
Oh, okay. Well, I will either post the answers or hand them out tomorrow to make sure that you got them all correct.
Yeah, that sounds great.
Okay?
Yeah, sounds great.
All right. Good luck at the game tonight.
Thanks. It's practice. We have a game tomorrow, though. So,
Oh, okay.
yeah.
All right. Well, try not to injure yourself at practice.
Yeah, I'm going to have to try pretty hard, huh?
I know. Bless your heart.
No, let's be honest. But, yeah, well, thank you.
All right. Love you guys. Talk to you later.
Love you too. Bye.
Bye.